I like the fact that you want to solve something that is not so, there doesn't have a clear solution. I always liked mathematics, and I actually started programming when I was, 11 or 12. Also, it's not that I wanted to become a professor from the beginning or that I wanted to do research right away. I wanted to learn more. My name is Vilanova. I'm professor in visual analytics at the Eindhoven University of Technology. Visual analytics is about making sense of data for humans. So what we do is we transform the data in visual representations. This is software we developed for diffusion weighted imaging. This could be the kind of images you get from the scanner. In our case, we get many of those. You cannot really look at them directly, so then you do some processing. For each position, here we have just one value, but in the case of diffusion tensor imaging, what we have is we have a tensor. So what you have is that at each position, you have something that looks like this. So at each position, you see we have these ellipsoids. So if it's very round in all sides, it means that the diffusion has no preference to go in one direction or the other. If you have a more elongated shape, it means the molecules have more the tendency to go in one direction than the other. So one thing that you can do in visualization is, interactively then generate fibers that would represent really the white matter structure that is in the brain and that we have. So what we do is you have algorithms that kind of simulate the reconstruction of these structures, and then you get things that look like this. So we manage also not just the reconstruction, but how you visualize things also. So we were working with Leiden Medical Center. The problem they had is that they were measuring cells, and for each cell, they have around 40 or hundreds of measurements. What they try to identify is whether they can see, for example, new cell types. At the time, there was no software that was able to look at this data in this way, that actually clinicians could use or researchers could use to look at that. And that's what we developed. We developed new ways, let's say, to look at this data and in an interactive way and that you can work with it. So one common thing that you use for that is dimensionality reduction. So the idea of dimensionality reduction is that if I have a 100-dimensional space, I don't need 100 dimensions to understand what is in the space. So I can have less dimensions. So imagine you have a lot of images, you just took a lot of images and you want to order them. So one option is, if you do dimensionality reduction, you would expect that images that have specific characteristics end up in a similar location in the space. So you can imagine you get images that are bridges or cars or whatever, get in one place, images that are from animals in the jungle, then get in another place. So if you do that in millions of images, it's nearly so small, you cannot see anything there. So one thing that was done is to develop a strategy such that you could analyze this million of images in a more structural way and hierarchical way. So if you have images, you could imagine that, instead of having 1 million of images at the beginning, I have done a kind of selection, and that's what I show. And then I can see, I have two clear groups. One is images of man-made things and images that are not man-made, that are natural images. And then I say, I'm interested in the natural images, so I can select this area and then go deeper. And I'm not looking at 1 million images at one time, but I'm going deeper at each of them, right? So I want the man-made images. Let's say I select this, and then I can see, I think I have cars and buildings in another group, and then I can say, I want to see the buildings, and then you go on like this, right? So at the end, you can still explore the 1 million images, but it's not just putting 1 million in your screen. That's not a good way to interact with it. I think one thing I like a lot is that this is multidisciplinary. So I like all these multiple aspects, but I also like the fact that we show things, that you have an image and that you have then, you make it useful for the users to work with it, right? It's a lot of fun to get this image. It's filming still? Hi.
Yes.